Good morning, algebra students. Sorry I can't be with you today. Happy Tuesday. Levi is not feeling well again, and my wife can't get out of work, so I'm home. I would much rather be there with you, believe me. Anyways, let's get going here. We're going to try something a little bit different. We have not had a video lesson in a while, and the last time we had one, it was off of a different method of instruction in terms of the presentation. So we're going to go right from the book here. And you're going to want your red notebook to accompany you. I'm not going to say that you need to take notes on everything. What I am going to say, though, is in terms of main concepts and vocabulary, you're probably going to want to write down those things as you go along, simply from a standpoint of study purposes. When we go to take a quiz on this material, you're going to want that at your disposal, and then obviously it's pretty good practice for what you're going to experience next year. At any rate, this is 9.1, quadratic graphs and their properties. Our goal, or I can statement, by the end of this, you will be able to, or you can, graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. Okay, so again, this comes from the idea that we had ax squared plus bx plus c, and we're obviously not going to be dealing with the bx term today. So we're going to forget about this. It's either going to be both of these, or it's just going to be the ax squared term at the beginning. So a is the constant that's in front of the x squared. That should be relatively familiar, and we'll kind of move on from there. So we're going to go ahead and skip this intro problem and just get right to the meat and potatoes of what we're talking about. So you can, it says, recall from chapter 8 that a polynomial of degree 2, such as negative 16x squared plus 64, is called a quadratic polynomial. That should look familiar. So a function is simply, as you've seen with linear functions, the rate of change is not going to be constant in this particular function. It says in the graph you're going to see is a U-shape. It can be right side up, it can be upside down, but you're going to have a U-shaped graph no matter what. And that U-shaped graph is called a parabola, and we will get to that just shortly. So something that you might want to put in your red notebook is that this key concept right here. So key concepts and definitions is kind of what we're going to be looking at in this particular lesson to give you a snapshot of what you're going to need for next year. So this is going to be a little bit confusing. So linear equations, we had slope-intercept form, we had point-slope form, and we had standard form. When you get to quadratics, it's slightly different. There is similar terminology, but the way that the forms look is going to be a little bit different. So standard form of a quadratic, you would think would look a certain way, but it looks like this: ax squared plus bx plus c, and standard form means that a cannot be equal to 0. If it is, then there would be no x squared term. So understand that. If a equals 0, well then 0 times whatever the x squared is equals 0, and then that x squared term disappears. So what's the point of having it there if if a is going to be 0? So here are just a couple of examples. Y equals 3x squared. Now that meets the requirements of just the y equals ax squared version that we talked about up above. Here is one that is y equals x squared plus 9. That meets the requirements of the ax squared plus c. And then lastly, you can have a quadratic that does have the bx term in the middle. We're not going to be dealing with that today, but understand that it can exist. Okay. There is something called a parent function, which it says is the simplest quadratic that there is. So simply y equals x squared is called a parent function. And all that means is that obviously the a is 1. There is no b, x, or c term that goes along with this. So this is in the structure of y equals ax squared and a equals 1. That's the parent function. In other words, when you think of parents, parents give birth to offspring. So any other equation is going to be offspring of this parent function. The graph of a quadratic is a U-shape called a parabola. We mentioned that. So again, it's a U-shaped curve. It can be right side up. It can be upside down. The name of this is called a parabola. And this is the parent function y equals x squared. That's the graph of this, and we'll show you how to come up with those. It says you can fold a parabola so that the two sides match exactly. This property is called symmetry. You've heard of that before. The fold, or the line that divides the parabola into two matching halves, is called the axis of symmetry. In this particular case, it happens to be the y-axis. As you can see, if I folded this parabola over this line, they would match, as it states. So the axis of symmetry can move left to right. It most certainly does not always have to be on the y-axis, but that is the most basic location of it. Okay. If you need to review anything from that, I know it was kind of rapid fire. That was only about 5 minutes worth of time, and that was a whole bunch of material. So if you need to go back and review that, please do. Otherwise, we're going to forge ahead. 547. So more terminology. The highest or the lowest point of a parabola is called the vertex, and the vertex lies on the axis of symmetry. When you have a situation in which the parabola opens upward, it's because a is greater than 0. In other words, it's a positive number. Positive lead coefficient causes this to open upward. If it opens upward, like so, the vertex, or the point at the bottom, let me change colors just so you can see it a little bit better, that point at the bottom, the vertex, is called a minimum because it is the lowest point of the graph. Likewise, if a is less than 0, in other words, a has to be negative, so you're going to have a negative lead coefficient, this will open upside down, and the point then that is the vertex will be the highest point, and that is called the maximum. Okay, so I don't know if that's counterintuitive or what, but you know, the parabola opens up, it has a bottom called the minimum, the lowest point. The parabola opens upside down, it has a top called the maximum. That's where the vertex is. Okay, so we'll just kind of take a look at these examples as we go through. Identify the vertex. So you're going to be using the coordinate plane, and you're simply going to be identifying the x comma y point at which the vertex is located. For example, this graph right here, you can easily see that the vertex is right here on the y-axis. So I'm going to have to go up 1, 2, 3 to get there. I didn't move left or right, so the point of the vertex is at 0, 3. And it is a maximum because the graph is upside down. This is the highest point, so it is also a maximum. Okay. Example B, regular U shape, right side up, which means it's going to have a minimum. Here is the vertex right here, which is the bottom point. And if you notice that I go 1 to the right and down 1 to get there, so the point is located at 1, negative 1, and because it is the lowest point on the graph, it is a minimum. For the time being, we're going to go ahead and skip the got it questions in all of the sections. If you want to pause the video and do it by yourself, certainly you're able to do that. I'm not going to go over any of them right now, simply for the sake of trying to get through the lesson as efficiently as possible and give you enough time to work independently on the end of the lesson. So we're going to go ahead and keep moving if it is all the same to you. Graphing ax squared. Okay, so actually graphing it can be kind of tricky at first, but if you get the hang of it and you have some number sense, certainly it becomes much simpler. So again, the fact that it is symmetric, it says, allows you to graph very quickly. So there are actually two strategies. I never really used the line of symmetry when I was graphing parabolas. Certainly you're welcome to it. I'm going to go ahead and give you the presentation that I was given, and it seemed to work better for me. But a lot of it depends on if you're more visual or if you're a more logical thinker. You have some more number sense, or stronger number sense, I should say. You're going to be able to do this a couple of different ways. So let's just think about the function here, y equals 1/3 x squared. First thing you want to identify is that when we're just talking about y equals ax squared, there is no plus c at the end, right? There's nothing here indicating that there would be a number tacked onto the back. We'll get to what that means in a second. Fact of the matter is, if there's nothing here at the end, this graph is always going to have a maximum or a minimum at the origin, at 0, 0. So if it is just y equals a squared, this will always have a maximum or minimum at the origin. You can see that the minimum is right there right now. So the origin is 0, 0 would be the minimum if it was asked for. So what we're going to do is graph the function. And again, create a table of values is the most efficient way to do it, I suppose. And then also we are going to name the domain and the range of this graph. And we'll kind of review and talk about what those things mean if you're not quite sure. So first of all, so from a number sense point of view, understand this. 1/3, a equals 1/3, right? The coefficient in front of the x value. This is a positive value, positive, which means the parabola is going to open up, right side up. Also, the fact that this is a fraction means that whenever this number, whatever number is that is inputted in for x gets squared, it's technically going to be divided by something, right? Or multiplied by 1/3 means it's the same thing as being divided by 3. So just kind of understand that in terms of the calculations that are going on. So here's what I mean by when you select a table of values, you need to have some number sense. It actually, I believe this is in your book. It says the plan over here. What are good values to choose for x when making the table? Well, based on the fact that the coefficient is 1/3, I probably want to choose numbers that are divisible by 3 so that after I square the value, you know, that number is going to be easily divisible by 3. So, and that's kind of the advice that it gives us here, because if I had a choice between graphing decimals, fractions, or whole numbers, I want to choose whole numbers all the time. It simply just makes me feel better, puts my OCD at ease, and allows me to have a very efficient graph in terms of where these dots are located on the coordinate plane. So that being said, I typically recommend this suggestion is that they use the line of symmetry, which is why you only see 3 values here. So I typically recommend 5 values, and I'll explain why. I recommend 5 values. The reason being, in this particular case, you're always going to choose 0. You're always going to choose x equals 0. Why? Because I mentioned that in this structure, the origin is always going to be the maximum or minimum. So I really want that thing right at 0. And then understanding if 0 is the max or the min, then I probably want to choose values that are equidistant from that point on opposite sides, negative and positive. So my recommendation here would be they choose 0, 3, 6. I would also choose -3 and -6. And here's what's going to happen. When I substitute these values in, I should get the same y coordinate, because all I'm doing is squaring 3, which gives me 9, times 1/3 gives me 3. Well, last time I checked, if I square -3, it's also going to give me +9, which when multiplied by 1/3 is also going to be 3. So the reason behind choosing positives and negatives that are same distance apart is that you should get the same y value. So this is also going to be -3, 3 for the ordered pair here. And this should be -6, whatever they got for +6, so +12. Why is that helpful? Well, when I go to graph this, here's what's going to happen. There's 0, 0. 3, 3, which means right 3 up 3. There's that point. 6, 12, which means right 6 up 12. Right 6 up 12. Their graph is going by 3s, no problem. I have number sense. I know what they're doing. And then I'm going to graph these other 2 points. -3, 3. So left 3 up 3, ta-da. And -6, +12. So left 6 up 12, ta-da. And you can see that now if I was able to connect those dots, it does not have to be perfect, but that's where my parabola is going to come from. This continues on infinitely in both directions. So I'm going to go ahead and put arrowheads at the end. And I am done with my graph. All right, so they discuss reflecting over the axis of symmetry. If you're comfortable with that, I'm personally not going to teach it. If you're comfortable with that and you want to try to figure it out on your own, be my guest. Otherwise, my recommendation, suggestion, whatever you want to call it, is to choose the same negative value as the positive value you chose on the opposite side of 0 so that you get the same coordinates opposite each other. Okay? Again, that was kind of a lot, so if you need to go back and review, absolutely go back and do that. I'm not done, unfortunately. I graphed it. Here's my table of values and here's my graph. The last part that is left for me to do is to declare the domain and the range. So flashback, domain is simply the x values that are a part of the function, and the range is simply the y values. And I'm going to use the graph itself to establish the x and the y values. So let's ask ourselves this question. If I was going to substitute values in for x, could I choose any number in the real number system? Yes, I could. Here's why. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number line continues, which means this parabola is going to go on and on and on forever. It's going to continue to kind of stretch out to the right forever, 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 which means not immediately, not anytime soon, but eventually it's going to get to like 100 and 200 and 300 and eventually 1,000 and etc. You get the idea. It's going to go on infinitely. The same thing is going to happen to the left. It's eventually going to reach negative 10 and then negative 50 and then negative 100 and then negative 200 and blah, 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 blah. So I could pick literally any x value that is real and put it in for x, and I would get a y solution. So we declare that by saying that the domain is all real numbers. The domain is a set of all real numbers. We won't worry about set notation right now. We're just going to say that the domain is all real numbers. Now, looking at the graph, if 0 is the minimum, right? That's the vertex right there. That means there can be no numbers less than 0 in a y direction. So the range, the set of y values that are a part of this function, are y is greater than or equal to 0. Y can be exactly 0. It's right there on the origin. And it can be numbers bigger than 0. For example, as these arrows go up, obviously the y values are increasing. But because the graph never goes below the origin, never goes below 0, I cannot have anything less than 0. Hopefully that makes sense. Again, we're going to skip the got it questions for now and simply move on. But again, if there's anything you need to review there, please go ahead and go back and do that. Otherwise, we're moving on. Page 548. Coefficient of the x squared term, it says, affects the width. In other words, if you kind of look at this, is it going to be skinny or fat is basically, the idea. So not trying to offend anybody, but those are kind of easily recognizable terms. Do we have a regular sized parabola? Do we have a skinny parabola? Or do we have a fat parabola? And again, that's based on width. And it has to do with the coefficient, in other words, the a value, the number in front of the x squared. Positive or negative has no effect. Let me repeat that. Positive or negative has no effect on the width. The only thing that positive or negative affects is it right side up or upside down. It has 0 effect on the width. Okay? So that being said, here's what we're doing. Use the graphs below. What is the order from widest to narrowest of the graphs of the quadratic functions? F of x equals negative 4x squared. 1/4 x squared, and regular plain old x squared. Okay, so if you were to graph each of these on a graphing calculator, this would be the graph of this function, this would be the graph of this function, and this would be the graph of this function. So that's actually really helpful to see it visually. You can see that this guy, even though it's upside down, is the skinniest of the three. This guy, right side up, is the fattest of the three, and this guy would be in the middle. So if I was numbering these 1 through 10, widest to narrowest, make sure you're following the directions, widest to narrowest, it'd be 1, 2, and 3. So it goes on to say again, 1/4 x squared is the widest, and negative 4 x squared is the narrowest. So they go in order like so. 1/4 x squared, and then negative 4 x squared. So again, the width is dictated by the coefficient. Positive or negative makes no difference. And basically, the smaller the fraction gets, the wider the parabola is going to get. The bigger the whole number gets, the skinnier the graph is going to get, the skinnier the parabola is going to get. So again, that might be slightly counterintuitive. Excuse me. Normally you think, oh, well, it's a fraction of the size, but it actually is the opposite effect. So fractions give you wider graphs, whereas whole numbers give you skinnier graphs. Okay. Next, finally, graphing y equals ax squared plus c. This is going to work very much like a y-intercept in a linear equation. All right. So as you can see, if I jump back up here, it says the value of c translates, which means slides, the graph up or down. Okay, so this is essentially the equivalent of a y-intercept of a linear equation. It's going to dictate where the parabola crosses the y-axis. All right, and we're not going to worry about moving things left or right for just right this second. All we're going to be worried about is moving it up or down. And again, based on what this says, the parabola is going to do what it is told. So how is the graph y equals 2x squared plus 3 different from the graph y equals 2x squared? Well, obviously the makeup of the problem is different. This has this plus 3. And this guy's going to do what he's told, which means plus 3 there is going to be up 3 from the origin. Right? So it is shifted 3 units up. Yes, it is. This is what we want right here. We want choice A. Okay? Reason being, if you look at the input values versus the output values, this is 11 higher than that. I'm sorry, this is 3 higher than that. This is 3 higher than that. This is 3 higher than that. Da-da-da, da-da-da, da-da-da. So the vertex moves up 3 spots, and so does every other point on the graph. They all move up 3 units. All right. And so if it was minus something, that would mean it would go down. Very simple. Easy to remember. Very similar to, again, the y-intercept of a linear equation. So if you can recall y equals mx plus b, just for comparison, y equals mx plus b. The b is the y-intercept. Remember that. If it's plus b, it's going up. If it's minus b, the intercept is going down from the origin. Same concept with the maximum or minimum of the graph. Plus 3 means that minimum in this case is going up 3 units. And if it was a minus, then it would be going down. Review that if you need to. Otherwise, we're going forward. We're actually going to skip problem 5, if I remember correctly. Yes, we are. We're not going to worry about the falling object model right now. We're going to skip that. So then we're basically on to the lesson check. I'm going to do 1 through 4 with you. We're going to do them all on the same coordinate grid. So if you want to go ahead and sketch yourself a coordinate grid in your notes, or if you want to go to the mailbox and help yourself to a piece of graph paper, that might be a little bit more suitable. You can also feel free to help yourself to graph paper as you do your homework so that you can graph these things properly. I'm going to go ahead and sketch a grid and then we can start graphing these things. Graph the parabola, identify the vertex. Okay. So you're going to want a table of values for each of these. Y equals negative 3x squared. Okay, so let's think about it. A couple of basics. First of all, negative sign means what? It's going to be upside down. So is there a plus or a minus c here? No, there isn't. What does that tell you? It is going to be right at the origin. So if the negative tells me that it's upside down, and there's no plus or minus c, meaning it's at the origin, that means the maximum is going to be at the origin, right there. Okay, so we're going to do this guy in blue. And negative 3x is going to be multiplied by whatever the values are here. So if I'm multiplying by 3, to be honest with you, it makes no difference what values you substitute in for x. So typically in a situation like this, here's what I would recommend. Again, I recommend 5 values, and I'm always going to use 0 when it's in this form, ax squared, with no c value, because 0 is the intercept, 0 is the origin, 0 is going to be one of the values I want to use. So for my xy table, not a whole lot of room here, I'm going to go ahead and do it up here, and then if I need to, I can erase it, I suppose. XY table, that's really close together. I'm going to use negative 2, negative 1, 0, 1, and 2. Why those numbers? Well, I would always use these numbers as long as I have a whole number coefficient. Easy to multiply, and they're opposites of each other. So obviously I know that this is going to be 0, 0, because 0 squared is 0 times negative 3 is 0, and that's where my origin comes from. I would do the positives first and then just understand that the negatives are going to be mirror images of these. So if I put a 1 in there, 1 squared is 1 times negative 3 is negative 3. And if I put a 2 in for x, 2 squared is 4 times negative 3 is negative 12. Which means when I put the negative 1 in there, I should also get negative 3. And when I put the negative 2 in, I should also get negative 12. So I'm ready to graph. I got my 5 values, 0, 0, and I'm going to do positive 1, negative 3, 1, 2, trying to make them about the same distance. So this is a sketch, not looking for perfection here. And then negative 1 on the other side. And 2 and negative 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. You get the idea. Positive 2 and negative 2 is over there. So this point is going to be somewhere in that neighborhood. Doesn't have to be perfect. This is right here. Again, we're just sketching. We're looking for a sketch. And it's going to be upside down. So typically what I recommend here, whichever way it takes for you to make a U shape. So I'm going to make this guy going down, connecting those dots like that, arrow at the end, and then round it off the other side through that point and through this point right there. And I'm done. Graph the parabola, identify the vertex. The vertex here is 0, 0. I'm going to go ahead and write that down. It is an ordered pair, so it should be in parentheses. And I'm finished. Okay. Go ahead and review that if you need to. Otherwise, I'm going to erase and start over. All that hard work gone. Oh well. Okay, 4x squared. Positive 4 means it's going to open right side up. No plus or minus anything, which means it's going to intersect at the vertex again. Damo. And it's going to be up this time. And it's also going to be skinny, right? Skinny. If there's a whole number here, it's going to be skinny. So table of values, again, whole number coefficient, I'm going to use negative 2, negative 1, 0, 1, 2. Why? Again, easy numbers to work with. There's really not a whole lot of math to do with the negatives either. If I do 0, 1, 2, then all I have to do is fill in the negative 1 and the negative 2 y values because they should be identical. I know this is going to be 0, 0. I can check just to be sure. 0 squared is 0 times 4 is 0. Awesome. 1 goes in there. 1 squared is 1 times 4 is 4. So that should also be 4. 2 goes in for x. 2 squared is 4 times 4 is 16. So this should also be 16. Boom. Got my 5 values ready to graph. These were all ordered pairs, by the way. 1, 4. Okay. 1 and 1, 2, 3, 4. All right. There's also going to be negative 1, 4, 5, 6, 7, 8, 9. Got a long way to go. 10, 11, 12, 13, 14, 15, 16. Probably a lot easier for you to count actual grid squares. 2, negative 2. So boom right there. And boom right there. And connect those dots. Keep it skinny. Again, not looking for perfection. If you're looking for perfection, you came to the wrong place. There we go. So there it is. I'm done. Identify the vertex. Again, the vertex here is 0, 0 because it's right at the origin. Good to go. All right, I'll give you a minute to kind of catch up with that. Review it if you need to. Pause the video if you need to do that because I'm erasing. 3. Y equals 1/2 x squared plus 2. Okay, now I have a situation here that my vertex is going to be moved up 2 spaces from the origin. The other thing I have here is 1/2, which means it's going to be wider than normal. And also because it's positive 1/2, it's going to be right side up. Okay, so there's kind of a lot going on here. Usually what I recommend in this instance, if you can remember this, is so negative 3x squared, for example, for number 1, technically this is plus 0, right? and this was the y-intercept. So this was also the middle value, right? The middle value of my table of values that I used. So there were a couple of suggestions here that they gave. Typically, whatever the denominator is, I want to pick something that's divisible by that. So I probably want to use even numbers as my whatever's being inserted in for x. And I'm going to kind of give you a trick to this. So just like in my table of values up here for 1 and 2, 0 is in the middle, right? I'm going to recommend putting positive 2 in the middle for this particular example, and I'll show you why in a second. So x, y table, because the graph is going to be shifted up 2 units, I don't know how helpful it is to actually have 0 as part of my values, unless it happens to come up. So let's put 2 in the middle, and then we're going to pick evens going one way or the other. So 4, 6, and then it happens to work out, 0, and then negative 2. So here's what's going to happen. Believe it or not, what should happen is that my answer for 4 and my answer for 0 should be the same. My answer for 6 and my answer for negative 2 should be the same. We're going to see if that holds true or not. So let's start with my middle value, 2. 2 squared is 4. Times a half is 2. Plus 2 is 4. Great. What happens if I put 4 in there? Well, 4 squared is 16. Times a half is 8. Plus 2 is 10. Great. Now, according to my logic, this should also be 10. Let's see if it works. It isn't. X squared 0 times a half is 0 plus 2 is 2. Okay, so my theory went out the door. That's okay. Negative 2 and positive 2 should yield the same result now, shouldn't they? So this should give me a 4. We'll verify it. Negative 2 squared is 4 times a half is 2 plus 2 is 4. Yeah, so 4, 2, 4, 10. And tell you what, let's scratch this and give me a negative 4, because my theory did not work. Negative 4 and positive 4 should yield the same result. Boom. Okay, excellent. So here's what happens then. Again, I recommend these values here for this. 2, 4. Let me use a different color so you can see. 1, 2. 1, 2, 3, 4 is right there. Negative 2, 4. Same thing other side. Right there. Okay. My vertex then is going to be right here, 0, 2, which is, boom, on the y-axis, 2 units above where it was before. And then I'm going to have 4, 10, 3, 4, and negative 3, negative 4, and 5, 6, 7, 8, 9, 10. So a point there, and a point there, and I'm going to connect like that, and I'm going to connect like that. Boom. So my advice was wrong. I'm going to skip number 4 for right now. My advice was wrong. Don't use this in the middle. Continue to use x equals 0 in the middle, because what you're going to find then is the y is going to not be 0 anymore. It is going to be whatever the intercept is. But then you're still going to want values on opposite sides of that. And again, in this particular case, because the variable is 1/2, you want to use numbers for the x values that are divisible by 2. So even numbers at any rate, positive and negative, so that you get an idea of the mirror image of that parabola. Okay, so again, if you need to pause, rewind, replay that stuff, please be my guest. If you are ready to work independently, here is my recommendation. This is page 550. This is going to be your homework. You're going to do numbers 7 through 25 all. 7 to 25 all. This is page 550. Okay, 550, it's right there. Page 57 to 25 all. Again, help yourself to the graph paper in the back in the mailbox. Should be on the bottom shelf. And then I recommend IXL skill. It's in Algebra 1. Algebra 1, BB1. Take a look at that. I know that this is pretty long. It's going on. My timer's going on 35 minutes. So I appreciate your attention. It was kind of, believe me, this lesson could have been a lot longer. I tried to speed it up and go as efficiently as I could. We're going to end up probably having to spend 2, maybe even 3 days on this, depending on how you work on it independently. I know traditionally the video lessons are even though you might find them effective, I think in terms of it's easier for me. I can't help you when I'm not there. So give that your best shot, and we'll check things when I get back, hopefully Wednesday, and go from there. Okay? Appreciate it very much. Do me a favor, don't give the sub a hard time. I don't care who it is. It might be Mr. Hernandez. It might even be Ms. Bartel. It might be somebody who's typically not in the building. I don't care who it is. Remember what week it is. It's Teacher Appreciation Week, and that counts for subs when they're there. So this might sound silly, but please treat the substitute the same way you would treat me. Maybe that's not with a whole lot of respect, but please take advantage of that opportunity. All right, and hopefully I will see you Wednesday. Thank you guys. Have a great day.